Welcome everyone to the MOOC, Designing Climate Neutral Industry and Electricity Generation. During this week and the next one, you will learn about industrial sources and types of emissions. You will also learn about the existing technological options, methodologies, and tools to mainly mitigate greenhouse gases emissions inside and outside the boundaries of the industrial plant. My name is Mar Pérez Fortes, and this week, together with Brendan Derrat, Paola Ibarra, and Samantha Tanser, we are going to drive you through the fundamentals of carbon dioxide mitigation measures in the industrial sector. In this first video, we are going to dive into the definition of the industrial sector, its contribution to the overall energy demand and greenhouse gas emissions, and I will introduce the CO2 mitigation measures that are going to be discussed in the upcoming videos along the week. The industrial sector is a segment of the economy that includes companies that create physical products that provide a service. Greenhouse gas emissions can be released from the transforming process itself and from the use of greenhouse gases as products, for instance, in refrigeration, as it was mentioned already in video 1.1 from the introductory MOOC of this series. The different types of existing industries can be classified by process and product, or by energy consumption. You can imagine that if industries can be classified by energy consumption, it means that they have the potential to be large energy consumers. They can consume large quantities of electricity and heat and have a consequent impact on greenhouse gas emissions. These figures show the annual energy consumption per region in terawatt-hour. The overall industrial energy consumption in year 2020 represents roughly 30% of the total energy use worldwide. Note that the trend is to increase up to year 2050. This trend is even more significant in non-OECD economies. The reason is the growth of heavy industries, like basic chemicals and steel, because of the development of regions. Remember from the first MOOC, video 1.4, that energy consumption is linked to the population growth and development. Despite the predicted declining trend of the industrial gross output growth relative to the other sectors, global industry-related carbon dioxide emissions are expected to grow, as we saw before, because of industrial development. The figure you can see in the slide represents the share of global greenhouse gas emissions by sector for year 2016. You can see that the largest share of global greenhouse gas emissions belongs to energy generation. The industrial sector is responsible for roughly 30% of the global emissions, around 35 gigatons of CO2 equivalent, being 25% of these emissions allocated to the energy use and 5% of them allocated to direct emission in industrial processes. But is it clear the difference between these two different origins of CO2 equivalent emissions in the industry? Let's take a look. On the one side, emissions from energy use correspond to emissions that proceed from the combustion of fuels to generate heat and work. On the other side, emissions from industrial processes that are not energy related proceed from the use of fuels in chemical reactions. We can distinguish then between the use of fuels as feedstocks, reductants, or directly used as non-energy products. In the slide, you can see a list of fuels which are natural gas, oil, coal, coke, biomass, and waste that can be used for energy purposes. These applications are, for instance, electricity generation inside the industrial boundaries of the process itself for heating, cooling, computers, or ventilation. Also heat production in a boiler, for example, for steam generation. Electricity and heat can also enter the system as utilities generated in, for instance, a centralized system outside the boundaries of the industrial process. But we will discuss this later. Fuels for non-energy uses are classified into three categories, as we saw before: feedstock, reductant, and non-energy products. Feedstocks are fuels utilized as raw materials in chemical conversion processes to produce chemicals. The major fraction of carbon remains in the manufactured product. For instance, natural gas can be used to produce ammonia, or coal can be used to produce syngas via a gasification. Fuels used as reductants are used when their carbon is utilized as a reducing agent. It happens, for instance, in the production of metals and inorganic products. The major part of the carbon is oxidized. Non-energy products refer to the streams that are produced in refineries and that can be directly used because of their particular properties. For example, lubricants can be used in engines, and asphalt is used for road paving. At the beginning of this video, we mentioned the boundaries of the industrial plant, which can be represented as in the picture on the slide. One single entity with several fuel streams entering the plant with different final energy and non-energy purposes. Nevertheless, this is just one specific situation, an isolated situation in fact, as normally industries are not isolated and tend to be grouped together in industrial hubs. Specifically, industrial clusters rely on the collaboration within and across industrial plants at different levels. For example, the plant from our example in an industrial cluster still receives raw material for energy purposes. However, it receives its feedstock from another company that generates it as a byproduct in its production process, and still receives hot stream from another company that generates waste heat. Moreover, the low temperature heat generated as waste heat in its own process can be used in households for heating purposes. I will continue now with an overview of the climate change or CO2 mitigation options that exist in the industrial sector. The first proposal is to decrease emissions by lowering the amount of fossil feedstock. This can be achieved by improving the material and energy efficiencies by switching to non-fossil fuel-based input and or changing the conversion process. For instance, via the use of the best available technologies, recycling, or reducing losses. In the image, the Sarna process for the iron and steel industry is an example of a technological alternative that performs better than the traditional blast furnace. Process integration advocates for using the process waste heat generated locally to produce electricity or to heat process streams, to decrease the use of external electricity and heat. This mitigation option will be described in video 1.4. The electrification of industrial processes favors the use of electricity-based technology options, avoiding the use of fossil fuels as raw material and using electricity instead. For instance, in the production of heat and chemicals. In the second one, the use of alternative raw materials is also needed. You can imagine that the source of electricity is crucial to propose an alternative that emits less greenhouse gas emissions than the original one. This mitigation option will be described in video 1.5. Carbon capture, utilization, and storage is an alternative that acts directly in the outlet stream, the stream that is released from the industrial source and contains carbon dioxide. Its aim is to capture, transport, and store it in geological sources, ideally forever. This mitigation option will be described in video 1.6. Through the videos of this week and the next week, we will talk about the pulp mill as an example of an energy intensive industry that has to decrease its climate change impact. A pulp mill converts wood into bleach pulp that is shipped into a paper mill. The paper, pulp, and printing industry as a whole is the fifth largest industrial source of carbon dioxide emissions worldwide. And the emissions correspond to the combustion of biomass. Let's go more in depth into the topic, and I wait for you in the next video. Thank you very much for your attention.